Okay, we want to practice impedance matching. Yeah, we can use this CST Design Studio. Yeah, you follow my step. Yeah, as I explained, you can do the same. Right, click on the CST Design Studio. All right, and so we have two port, right? Yeah, click on the external port. Place one here and place another somewhere else. All right. By default, the port is 50 ohm, but we have a load here which is 15 plus J15, right? Yeah, we can use this second port to represent that load. Okay, so you right click on port 2, yeah, and go to property. You want to change the impedance, right? Yeah, we have 15 plus J15, 15. Okay, so if we connect these two ports, right? Yeah, of course, when we run the simulation, we will get some impedance mismatch, right? So in this experiment, we want to use a T network. Yeah, so you go to circuit element under the block selection tree. Yeah, the block selection tree, you go to circuit element. There are some ideal inductor, capacitor, resistor, and so on. Alright, you can drag and drop. Yeah, we need two inductor. Alright, yeah, and then we need one capacitor, right? To rotate the capacitor, you can just type on R or L, yeah, it will rotate. Yeah, it will rotate right or left. Okay, and of course we need to have ground. Yeah, put the ground there, and now you can connect them. Yeah, just double click on the port and then connect it to the component. Double click on the terminal and connect it to the port. Okay, connect them, connect a T network. Okay, yeah, so now we have a T network, right? Port 1 is 15 ohm, port 2 is 15 plus J15, right? So what are the component value that we need, yeah, in order to perform the impedance matching, right? We can give it a variable so that later on we can tune. Let's say you click on the first one, you right click and go to property. Maybe no, you don't have to do that. Yeah, you can just go to the value here. The value here, right? Inductance. You click on the value here. Okay, double click, right? Yeah. Let's say we call this L. Let's say I call this L2, yeah, because I want to call the other one L1. Okay. Yeah. Let's say I give it a value of 15. Yeah, 15 nanohenry. Okay. And then another inductor. Yeah, click on it. Yeah, let's call this L1. Yeah, 15. Okay. And then for the capacitor, Similarly, give it a name. Let's say we call it C3, right? What is the value, right? Okay, we can use 15. Okay. All right. Yeah. So now we have connected the component. Yeah, we can start the simulation. Go to new task. Click on the S parameter. Maybe we want to run the simulation up to say 10 gigahertz, right? Yeah, and then we want more point. Yeah, you can add a 0, and so that you have more number of point. It may not be necessary. Yeah, if you are okay with 1,000 point, yeah, just leave it with 1,000 point. Okay, may be sufficient. Okay. All right. Yeah. So if you are done, you can update. Yeah. Oh, it's done. Although there are so many points, yeah, the simulation doesn't take very long. Go to new task. Yeah, and the new task. Alright. So now you can go to the navigation tree to look at the simulation result. This is the value of S11. Okay. So you see the reflection coefficient is very bad, right? 0 dB. Yeah, almost everything is reflected. Yeah, and S12 is the signal transmitted to the load. Yeah, in this case the load is the 15 ohm load. Yeah, remember that port 2 is 15 plus J15, right? So the reason is the value that we have selected is not suitable, right? So let's do some tuning. Yeah, go to S11. Under the 1D plot, we can look at Smith chart. Use Smith chart, right? Yeah, when we perform impedance matching, right? So this is the value of S11 versus frequency, right? Yeah, at 0 hertz, yeah, the reflection coefficient is this value, and the impedance is 15 plus J15. Yeah, impedance is given here, and then at 10 gigahertz, yeah, the reflection coefficient is this value, yeah, on the Smith chart. Right. So we know that we will not be able to get impedance match at all frequency, right? Yeah. So you have to choose what frequency you want to work at. Yeah. At which frequency you want to perform impedance matching, right? We can put a marker. Yeah. Add a curve marker. Yeah. Let's say. All right. So this marker is at the frequency of 0.143, right? Yeah, you can change the frequency by dragging it. Yeah, you can drag it to another point, or you can choose the marker. It's hard to choose, right? Let's see. Yeah, let's select the marker. It's hard to select. Okay. Oh no, is that the marker? Okay, alright, yeah. So you can double click on the marker and then you can choose the frequency. Let's say I work at 1 gigahertz. I want to perform impedance matching at 1 gigahertz. Oh, no, cannot.